let's find the magnitude first. Magnitude is r equals our components squared and added. So r equals the square root of 2 squared plus 3 squared. So that's going to equal 4 plus 9, which is the square root of 13. All right, that is our magnitude. Done with that. Directional angle. I always draw my picture because that's... Can't tell you how people get it wrong because they just have no idea where this actually is. 2, 3 is right here-ish. I just really care about what quadrant it's in. Because now when I drop my... That's a terrible 90 degree. That's better. All right, we are going to have our x value is 2, our y is 3, so it's over 2, up 3. Your theta angle, guys, your theta angle is always the one that goes in this direction. So that means your theta is actually just that angle there, that part of that triangle. So that means we're just going to find our theta, we're just going to take the tan inverse of our opposite, which is 3 over 2. In other words, tan inverse of always your y over your x will get you your angle. Now's not the time to work on homework. Which is going to equal about 56.3 degrees. There is no reason to add or subtract it to anything because that is, in fact, your theta angle. The only time you need to add or subtract is if you're in quadrant 2, 3, or 4. Otherwise, it just remains 56.3 degrees. If you don't know what I did here, you need to work this weekend because this is about the easy problems on the test. All right, any questions on this? Not so much that, more that. All right, then questions from the homework. Mary.
Mine's probably a general question.
Cool.
41, 43, 47, 49. So I didn't simplify. Well, no, it's like it's the same question for like.
Gotcha. All right.
Okay, so I didn't simplify them all the way because we didn't do it that way in our notes. Are we supposed to?
Well, that's why you have to look at so it says perform the indicated operations. If you looked at your notes, it just said perform the indicated operation. It just said do the multiplication. But then it does say write the answer in A plus BI. And it says use a unit circle when possible. So that means it's not reducing. It really isn't reducing. It's just seeing if you understand. If I tell you what form to put it in, you have to leave it in that form.
Right.
All right, so I might say, maybe on the test it says perform the indicated operations and leave it in trig form. You have to know what trig form is to leave it in that form.
Mm-hmm.
So it really is, do you understand what it is, and then do you know how to get to it?
Okay.
Okay, so it's 2 problems in 1, kind of. Does that make sense?
Yeah.
That's why you had to do it there
Okay. Sounds good.
versus what we did in the homework. All right, other questions? Yeah, Nora.
I'll go through 51 because I understand how to do it, but I don't know why I got the wrong answer.
Okay, yeah. Okay, so the first thing we need to do is we need to put them into trig form, correct?
Mm-hmm.
So when I'm doing the trig form of 4 comma 4, our magnitude should be 4 squared plus 4 squared, which equals 32. Square root of 32 is really 4 square root of 2. If you left it as square root of 32, oh well, life goes on.
Yeah.
But you should have those general numbers. We're in the first quadrant. So it'll be the tan inverse of 4 over 4, which is 45 degrees, and we leave it as 45 degrees because 45 degrees is already in the first quadrant. No need to do the 180 or 360.
Yeah.
Did you get that one?
I got the first part. Like I got the numbers.
Oh, you got all. So you got 225
And 45.
and the 45 degrees on this one,
Yeah.
and then you came up with these 2 equations.
Mm-hmm.
Okay. So to multiply, we first multiply that 4 square root of 2 times 5 square root of 2. Well, let's look at the 4 and the 5. 4 times 5 is 20. Square root of 2 times square root of 2 is 2.
20 times 2 is 40.
Is 40, and that's where we have the 40.
Okay.
Then we add our 2 angles. So that would have been 225 plus, oh wait, did you say this angle is 45 degrees?
It's 1.
But it's in quadrant 3, so it has to be 180 plus 45, which gives us that 225.
The other one's 45 though.
This one's 45. But I believe,
I have that.
you have the 225?
That was right.
Okay, so then we have 45 plus 225, which equals 270.
Yes.
So that's for both of them.
Okay.
And then we have 40 times that cosine of 270. So you got that one now?
Yeah, I got that one.
Okay. And then 4 square root of 2 divided by 5 square root of 2. Square root of 2 is square root of 2, cancel out.
Oh. Okay.
So we just have 4 over 5, and then we subtract. Our first angle was 45 degrees.
Mm-hmm.
Our second angle was 225. So it's 45 minus 225, which equals negative 180.
So it's a 225 minus 45, so I got a positive 1.
Don't do that. Look at which one is your first one and what is your second one. You have to do it in order. Jacob.
For the like 4, comma 4, and negative 5, comma 5,
Mm-hmm.
if I just leave like radical 32 and radical 50 for the final line, is that okay, or points off the test?
Depends how generous I'm feeling.
Okay.
You should really have it simplified here because it simplifies down to 4 over 5. But if you didn't have the stuff, sometimes it messes up and you don't actually know what it simplifies to. If I just asked for the magnitude, he said square root of 32, I'd probably be fine. But when you start having to divide or multiply, then that's where that simplification really...
Can't see that.
You can't see it. Yeah, exactly. Yeah, Hope.
Number
49.
49.
49 is 4.1 times cosine of 36.7 plus I times sine of 36.7 all over. So the first thing we're going to do is we're going to do that 4.1 divided by 8.2, correct? Which came out to 0.5. Then we have to do 36.7 minus 84.2, which should come out to that negative 47.5.
Yeah.
So you have all that?
whole part I got. Yeah.
Oh, okay.
The part I'm having trouble with is putting it in the A plus B
Oh, okay. So let's just talk about how to, maybe I made a mistake. I don't think so, but maybe. So I think there's several ways to do this, but an easy way to plug this in your calculator is to actually put 0.5 in your calculator and then multiply by cosine of negative 47.5. Does that come out to 0.34?
Yeah.
That is me distributing that 0.5 to both of these.
Okay.
Then you take that 0.5 in your calculator and multiply by the sine of negative 47.5, and that will come out to a negative 0.37.
Okay.
All right, so that's kind of how you can do it in your calculator. But it's the same thing, it's just distributing.
Mm-hmm.
Other questions from the homework? Yeah, bro.
I have a general question. So
Cool.
how many like decimals could we be off? Like I got 0.37 or 0.36.
You're probably fine as long as you got close to what. Because what could have happened is, if you look at, I kind of did it both ways on here, where sometimes I do the cosine of negative 47.5 and then I round it and then I multiply it by the 0.5. So we're going to get a couple decimal points off depending on how you do it. Best bet is actually do kind of what I told Hope to do, especially when you're on like a big standardized test. Keep things in your calculator as long as possible. So I would honestly do 0.5 times cosine of negative 47.5 and then round it to like the 10th place or something. But on like a test, you're fine. Other questions? Okay. Then let's talk about the polar coordinate system. There's some spirit. Let's hear it.
That was weird. That was hilarious.
I'm just saying.
We all good? Okay, now let's talk about the polar coordinate system. So up until now, basically you've worked in the rectangular coordinate system. Your rectangular coordinate system worked as you had vertical and you had horizontal. You had horizontal being your x, you had vertical being your y. We had the x, y plane. Well, the polar system works on the same general concept. you need 2 bits of information to move around it. Rather than up, down, we're going to have a distance and an angle. So that distance, most of the time we call it r. So that distance is going to be an r value. And that angle, we're going to call theta. But if you recognize, those are the exact same terms we were using for vectors and complex numbers. These all work on basically the same system. It just has different names for it. So let's talk about the coordinate, our coordinate plane that we have here. So first of all, when you're doing an XY system, you usually have that point 0, 0, which is called your origin. With the polar equation, that point 0, 0 is now going to be called our pole. And the axis that runs kind of left and right or horizontally is our polar axis. That theta is just an angle. And that r is a distance. But realistically, this is exactly what we did for vectors for the most part. We found a magnitude, which was the length of a line, and we found an angle that it was at. Now it basically has its own plane that we're no longer putting on the xy. We're going to put it on kind of its own coordinate system based only on distance and degree of angle. Mark, can you pick up your head? Thank you. Once again, this point is going to be distance and a given angle. All right, so let's see how to graph that. So we have to graph 2, 45 degrees. What we're going to do is this 2 is going to be the length that you go out. Now the weird part is 2 is actually anywhere on this circle. This is actually your 2. But we try to match it kind of with our xy coordinate plane because that's what we've done our whole life. So what we're going to do is we're going to label this 1, 2, 3, -1, 2, 3, so we can see what those measures are. So I'm going to label that 1, 2, 3, -1, -2. Yep, get rid of that line. And -3. All right, with 2 45 degrees. Oh, I'm on the wrong one. That's okay. -3, -2, -1, 1, 2, 3. We got to label that one anyway. All right, so we are doing 2 45 degrees. So what you're going to do, let's see if we can make something sizable. You're basically on your left, right, you're going to go out to +2. And since it's 45 degrees, it's going to work just like the unit circle, where if it's a positive angle, you're going to go counterclockwise. That'd go the opposite way for you. It's hard to do it in the wrong way. And if you are negative, you are going to go clockwise. So in this one, I want to go counterclockwise 45 degrees. Let's see if I can get something that stands out. No, probably not that. Maybe purple. So on that 2 line, whew, that's got to get a bit, that was a bit aggressive. So we're going to go out to about 45 degrees, which is right here, because we can picture that line. That would be 45 degrees out here. So that right there is the point 2, 45 degrees. And it's just a point. It's not a vector. It's just a point. The only reason why I do that straight line is so you can visually see that you go out 2 units and up here. All right, our next one is -3, -150 degrees. So on this occasion, we need to go back 3 units. So we're going to go left 3 units. And from that point, we are going to go -150 degrees. Negative means you're going clockwise. You are going clockwise to go negative. I'll say those words several times. I know several of you won't write this down. But once again, positive is counterclockwise, negative is clockwise. So that means I need to go up. I need to follow that line until I get to 150 degrees. So we have to recognize that each of these, in this case, are 30 degrees. So this would be 30, 60, 90, 120, 150, so we'd end up there. So going around, we'd end up right here, would be -3, -150. The weird thing about the polar coordinate system is point 3, 30 degrees, is that exact same point. It is exactly the same point. So picture out +3 with a +30 degrees. That would end up at the exact same point. So with the polar axis, things can often repeat themselves. All right, just like with anything else, we don't have just degrees. Sometimes we have radians. And so this one's going to be the 0.3 pi. So we'd go out 3 units. Maybe I should label this first. 1, 2, 3. We'd go out 3 units, which would be here. And then we go around pi units. Since it's positive, we'd go counterclockwise. So we went out all the way around, and this is my 0.3 pi. And finally, we have 450. Well, 450 just means it's going around the circle more than once. Yeah, Nora.
Can you clarify why at some points you just go up? So like in the first graph, when it's just said, or actually on the second graph. So, never mind, I just answered my own question. Sorry, thank you.
Yeah,
Sorry.
I nailed it. Woo! Mary.
For the counterclockwise versus the clockwise, it's only the angle for positive and
Only the angle. Yep. Because the negative or positive just tells you where to go left or right to start off with. So you basically just pull your finger on it. So remember,
Bless you. Bless you.
these blue and dashed lines are really just guides. Like on the homework, you'll probably just put your finger and find that point. All right, you don't have to draw all those lines on there. All right, the last one is 450. 450 is bigger than 360 degrees, so that means you're going to go all the way around.
Ooh.
And then you're going to keep going. So rather than going all the way around and then keep going, what I'm going to do is we're just going to see how many extra circles there are in there. So we're going to take that 450. I don't know why that one is so big. So we're going to take the 450, and we're going to subtract 360 from it, and we're going to come up with just 90 degrees. So the point 450 is going to be the exact same point as 290, which means you'd go out on that, let's label this 1, 2, 3, -1, -2, -3. So you'd go out 2 units, and then you go up 90 degrees. So we're just going to put a point right thither. And that would be 450 or 290. Should put some degree symbols on there. They're both the exact same point. All right, questions on plotting those? Yes?
what if it's like 0, a degree? Where would you put it? Because it doesn't go out.
Exactly.
So you just put it on like the side?
You'd put it on because
On the pole.
it's just a point spinning around. Yep, you just put it right at the pole. Yes, I saw your hand.
For like the 450 minus 360 or equals 90,
Mm-hmm.
if you don't show that like, on a test, and you just do like just show it, will you be upset?
Say that again.
If you don't show the
If you don't show me the work and you just put the
Yeah.
point in the right place,
yeah,
you're fine.
okay.
Because on the test, I'm just looking for the point. Did you put the point in the right place? If it's in the wrong place, then I'll look for what did you do. Yeah, Mark.
Are we gonna get ours that are like square root of 2 or something? And does it even matter? Like, could we just put square root of 2 on one of the lines?
Well, you just, yeah. What's the distance to square root of 2, right? So you could plug that in your calculator. It's a little bigger than 1. So if it was
So
square root of 2, you just go about here.
Okay.
So there's stuff in between. So like 1.5 exists there.
Oh, okay.
It's just you have to put it between those 2 marks. It's kind of like the x-axis where you mark 1, 2, 3. Everything exists in between. It's just you can't put enough marks on there to do everything. Wrong guy to talk about marks, huh? All right. The next thing we're going to talk about is converting polar to rectangular coordinates. That graph looks awfully familiar. This is the third time we've seen this. So our okay, it's like the fourth time we've seen it. The first thing is this r and theta is going to be our polar form. This x and y are rectangular values. So if I have to find my x and y values, we're going to use cosine and sine. So if we have cosine of theta, cosine is adjacent over hypotenuse. That would be x over r. And so we'd have x equals r times cosine of theta. This is the third time we've had that exact same formula. It was the same thing for vectors for component form. And it's the exact same thing for when we did our complex numbers. The next thing we're going to do is our sine of theta equals y over r. Once again, turns out y is going to equal r times sine of theta. Boom, boom, boom. New road, same destination. All right, so right now we have an r value that's 6 and an angle of 210 degrees. So this is my r value. This is my angle. In other words, this is my magnitude. This is my directional angle if we were talking about vectors. Same exact stuff. In fact, we're talking the same thing. 6 is a length. A magnitude is also a length. So this says convert it to rectangular coordinates. Yeah?
In like that form, like 6, how many go to the right? Like
6 would go to the right. So it'd be over 6 and whatever degree it measure it would be.
Wouldn't 6 equal the x value for the two bottom?
Just these are the points up here.
Oh, okay, yeah.
But they coordinate to an x and y value. Okay? So basically I'm taking a vector and swinging it, saying that this is the length of the vector and this is the degree measure, and then we put the triangle to help us find those x and y values. All right, so our x value is going to equal r times the cosine of the angle. So that's 6 times the cosine of 210 degrees. Our y is going to equal 6 times the sine of 210 degrees. Woo! 210 degrees is on a unicircle. This is a problem I can say you cannot use your unit, or you can't use your calculator for. Who thinks they know what the cosine of 210 degrees is? Oh, cheater, but go ahead. Negative square root of 3 over 2. At least he did work, though. So that one's just going to be x equals negative 3 square root of 3. Our y value, since 210 is in quadrant 3, both have to be negative. Square root of 3 over 2 always matches up with 1/2. So that's going to be 6 times a negative 1/2. So y is going to equal a negative 3. It asks us to put it in rectangular coordinates. So that means you should put it as negative 3 square root of 3, comma, negative 3. Yes?
Would you take off if we just like used our calculator? Like,
How would you use it?
just 6 times cosine 210.
Well, if I said not to, it'd probably be in a section of the final that you can't use your calculator on. And yes, if I said you can't use your calculator and I see that you rounded everything, then you'd probably get like half points or something.
Wouldn't that be just cheating?
Well, you'd still know the forms, right? So you get the half points for knowing the right forms, but you lose the other half of the credit because I said you can't use your calculator and you did. Okay. The next thing is converting rectangular to polar coordinates. First step is, well, for polar coordinates, you need r and you need theta. What does r equal?
X squared plus y squared. Square root.
Yep. Square root of x squared plus y squared. And this angle right here is just your directional angle. So in fact, I'm just asking you to find the magnitude and the directional angle again, which is what you just did for bell work. Except this time you're going to put it as coordinate points. All right, so to find my r value, we are just going to go r equals the square root of negative 3 squared plus 6 squared.
Yes.
3 squared is 9. 6 squared is 36. So that's the square root of 45. 9 goes into 45. Last time I checked 5 times, so that's going to be 3 square root of 5. That's my r value. Just circle it. Directional angle. I'm going to take the time to actually plot this point so I don't get anything wrong. It is negative 3 up 6, so it'd be somewhere over here. Let's make our triangle out of that doohickey. Our horizontal is negative 3. Our vertical is 6. Just a reminder, the theta I'm looking for is that big angle, because we need to make that all the way to quadrant 3. So my answer should be somewhere between 90 and 180. If it isn't, it means I need to do something with 180 in this case, because our beta is the little angle right there that helps us get it. To get that beta, we're going to say beta equals the tan inverse of our y value, which is 6, over our x value, which is negative 3. And that's going to be about, what was that?
116.6.
Oh, that's going to be our final answer. This one's actually our negative 63.4 degrees. What the answer Nora was giving me is that our theta should actually equal 180 minus 63.4, which is then going to equal that 116.6 degrees. Notice it asks for, it wants the coordinates. So we're going to put it in coordinate form where it's 3 square root of 5, comma, not negative, it's a positive 116.6 degrees. And so if you plotted right now, if you had an XY coordinate plane, you plotted negative 3, 6 on there, and then you put a polar axis on top of that and plotted that point, it'd be in the exact same location. Pretty snazzy stuff. All right, guys, the rest of the time will be for you to work on the homework. Note the first 1, 2, 3, 4, 5, 6, 7, 8 problems are plotting all those points on one polar coordinate plane. It's a little different than the one we used in class. It's got a little more information on it. So you probably don't want to draw a thick line and a point and then dashes. You probably just want to find it with your pencil. Otherwise, you're going to have way too much happening on there. Do you get what I mean? Okay.
Yes.
All right.